Hi guys, welcome back to our channel Helm of Science. So in my previous video I had started the chapter light and I had covered the basic introduction on the chapter light, and I had discussed few topics like the laws of reflection. I had discussed about plane mirrors. So if we recapitulate a bit, I had discussed plane mirrors. What are plane mirrors? If you remember, plane mirrors plane mirrors had one side which was reflecting and the other side was polished. So this kind of mirrors have one reflecting side and one polished side, generally polished with silver or aluminum. So if we consider this as a plane mirror, one side will be polished. I am denoting this side with these dashes to represent it as polished. So this is the polished side and this one is the reflecting side. So if a light ray falls on it, it gets reflected from this reflecting side. So now in this video I'll be discussing an important topic, which is characteristics of images formed by plane mirrors. Characteristics of images formed by plane mirrors. Now let me first write down the characteristics, then I'll discuss the characteristics in detail. So which this topic which I am going to discuss is very important for the exam, so please keep this in mind. So the first characteristics of images which are formed by a plane mirror is the image formed is virtual and erect. Number two is size of image is equal to size of object. Number third characteristic is distance of image from mirror is equal to the distance of object from the mirror. And the last characteristic is lateral inversion. Okay, so now I'll discuss these characteristics in detail, rather say lateral displacement we can say. Now take an example. If I stand in front of a mirror, what kind of images do we see? Like we know that if we stand in front of a mirror, we can see that the image which is formed appears to be formed behind the mirror, isn't it? Like when we stand in front of the mirror, the image is formed behind it. Thus, such kind of images which appear to be formed behind the mirror are nothing but virtual images formed. These are not real. So, one basic difference between a virtual and a real image is that virtual images are formed on the other side of the mirror and real images are formed on the same side of the mirror as that of the object. Now, let's take an instance. Say I'm sorry. Let's say this is the reflecting plane mirror. Okay, sorry. And this is the object. This a bar is the object. Now we know, let's say that reflecting ray is reflected from the object to the plane mirror. Okay, so this, if you notice that this reflecting ray is normal, like it's along the normal. So what do we know, that if the ray is along the normal, so the angle of incidence for this ray becomes 0. So this ray will, after reflecting from the surface of the mirror, will retrace back its path, so angle of refraction will be 0. We know this from the laws of reflection, which I had discussed in the last video. So okay, so this ray will retrace back its path, so it will come back to its original path. Let's take another ray which is reflected from the object and it strikes the mirror somewhere here. Okay, so if we draw the normal here, so there is an angle of incidence, right? So this ray will be reflected back from the reflecting surface of the mirror with an angle of incidence r, angle of refraction r, which is nothing but equal to this angle of incidence, right? So now if we retrace the this rays backwards, if we retrace the path of this rays backwards, and join these two rays together, we get an image which is erect in nature, right? We get an image which is erect in nature. Also the image is formed on the other side of the mirror, so this is a virtual image. So the image which is formed is virtual and erect. Like if like we notice that when we stand in front of the mirror, it seems as if the image is on the other side of the mirror, but it is actually not. Actually it's just a, like, it's our perception that it is formed on the other side. The mirror is polished in the backward side, right? How can the image be formed on the other side? But it appears to us as if it is formed on the other side. So one important point you have to keep in mind is that virtual images are always formed when the rays are not converging, they are diverging rays, right? This ray is diverging, so virtual images are also always formed when the rays are diverging in nature, formed when reflecting rays are diverging in nature. Now if we notice from the image, what we notice is that the size of this object a bar is equal to the size of the image which is b bar. So uh, the image formed is virtually infinite. We got size of the image is equal to the size of the object. So this size is equal to that b bar. So image characteristics of image formed by plane mirrors is that the size of the image is always equal to the size of the object. Now this distance, which is the distance of the object from the mirror, is equal to the distance of the image from the mirror. So this point also we get from this image. Also there is lateral displacement. What do we mean by that is that if we stand in front of the mirror, our left side becomes the right side of the image formed, and the left becomes the right and the right becomes the left. So this is known as lateral displacement. If we write the letter P on a piece of paper and we stand in front of a mirror, if we P is seen in the image as the opposite. So this is known as lateral inversion or lateral displacement. So these were the properties of image which are formed by a plane mirror. So this topic is really very important for your exams. Often questions are asked and you have to keep in mind all the points which I have discussed here. So we will next move on to the next topic, which is spherical mirrors. So up till now I had discussed only about plane mirrors. Now I'll discuss about spherical mirrors. I'll give an introduction to spherical mirrors. Now, spherical mirrors. Now, before moving on to spherical mirrors, I'll discuss why did we need spherical mirrors if we already had plane mirrors for reflection. Let's take a simple example like the rear view image, rear view mirror which we have in our cars. Those mirrors are spherical mirrors. Now, in place of spherical mirrors, if we had kept plane mirrors in the as rear view mirrors, what are the characteristics of images which are formed by plane mirrors? First, we have to consider that the characteristics are what the size of the image is equal to the size of the object, right? And the distance of the object from the mirror is equal to the distance of the image from the mirror. So if there is a truck behind our car, right, so the image size will be same as that of the truck, so we won't be seeing anything other than the truck in place in if we kept the plane mirror in place of the rear view mirror. So what plane mirror gives is that the let's say the car which is behind it gives an image of only that car. So what we need is that basically a mirror which gives a much more wider view, so that we can see the entire traffic which is behind us, the entire road which is behind us. So spherical mirrors are used in place of plane mirrors in our rear view mirrors of our cars, so that because they give us a much more wider view of the traffic behind us. So this is one of the few uses of spherical mirrors and why it is used in place of plane mirrors in certain cases. So if we start with what is a spherical mirror. So a spherical mirror is nothing where the curved surface or the reflecting surface of the mirror, where the reflecting surface of the mirror is curved inwards or outwards, where the reflecting surface of the mirror reflecting surface is curved inwards or outwards. Now, another property of a spherical mirror is that a spherical mirror is a part of a hollow sphere. Spherical mirror is a part of a hollow sphere. Now, let's take an example. So, by the word spherical, we know it is round. So, let's take a hollow sphere. Sorry. Now, if we bisect this hollow sphere into two parts and take this part, the right hand side part of this sphere, we get something like this. Yes, so we get something like this. So for in case of a hollow mirror, we have two sides, which is a convex and a concave. So let's forget mirrors about for 1 second and we concentrate on this side. Though this side is inverted, this is this side. I'm talking about this side. This side is bulging inwards. So this side is known as a concave side. Concave side. I'm not talking about mirrors, mind you. This side which is bulging inwards is known as concave side, and this side which is this side which is bulging outwards, it is outwards bulging, so it is known as the convex side. But do we see any reflecting surface or any polished surface in this part? No, like there is no polished surface, so we can't call this as a mirror. But however, if we take a mirror which is shaped such that the outward part is polished and the inwards which is curved inwards, this type of mirror is known as a concave mirror. Concave mirror. And the if we take the opposite, where the polish is towards the inside and the mirror is curved outwards, that type of mirror is known as a convex mirror. So there are two types of spherical mirrors, which number one is concave mirror and number two is convex mirror. Now if we take the sphere example again, okay, so if we polish this surface, so the reflecting surface is towards the inside and it's curved inwards, so this surface becomes a concave mirror. And if it is polished this side inwards, so this reflecting surface is curved outwards, so this surface becomes the convex mirror. Thus we say that spherical mirrors are part of a hollow sphere. That is why this is the example why we call it as a part of a hollow sphere. I'll quickly do a comparative study between concave and convex mirrors. For concave mirrors, we have the reflecting surface. This is the reflecting surface. We have the reflecting surface towards the center of the hollow sphere containing it. Okay, so if we consider this as a center, so the reflecting surface is towards the center of the hollow sphere containing, and the other side is naturally polished, so the other side, let's say B, is naturally polished. Now for convex mirrors, the thing will be exactly opposite. For convex mirrors, it will be something like this. If this is the center of the hollow sphere containing the mirror, the reflecting side, which is this side, is away from the center of the hollow sphere which is containing the convex mirror. So the reflecting surface is away from the center of the hollow sphere containing it, and naturally the other side, which is, let's say this side is B, then naturally the other side which is polished is towards the center of the hollow sphere. So in this video I have discussed the properties of images which are formed by plane mirrors, and I have also given you uh, introduction to spherical mirrors. What are the kinds of spherical mirrors, what are spherical mirrors, and I have also discussed why do we need spherical mirrors in place of plane mirrors in certain circumstances with an example. So I'll wrap this video up here, and stay tuned for more videos on this chapter light. I will discuss the spherical mirrors in details in my further videos. So if you like this video, please subscribe our channel.